Hello everyone, good evening. This is our second lecture in Python. So we'll try to learn the comparison of relational operators in Python and logical operators and the application of them in real life. So I will try my best. So first, do you have any idea about the comparison of relational operators or logical operators in Python? Have you any idea? Anyone has the idea? Nobody? All right. So is my voice clear?
Yes, sir. Your voice is clear.
Okay. All right. So, okay, some people are sending emails. They are confused about the time and etc. etc. And and some people ask, what is the class schedule? But I have already sent through email. So they're not careful about the training, or they're not serious at all. So they're asking about the time now. It's very bad. I have already sent the schedule and I said, what is the time for the training? By the way, okay, we use these operators to compare values. Okay, the comparison of relational operators we usually use to compare values. So say for example, if we want to compare like x is greater than y, or x is less than y, or x is equal to y, or x is not equal to y, or x is greater than equal y or less than equal y. We need it. We need it for our data access. We need it for our scientific data analysis or whatever, to solve our problems, right? We have many problems. If we do one by one, it will be very difficult. So that's why we need these operators, and it will help us a lot. Then we have the logical operators in Python. In logical operators, we use it to test if operands are true or false. Like even the comparison or relational operators, you will get the output in Boolean results. Do you know the Boolean logic? Boolean. Do you have any idea? Boolean is just true and false. Okay. So it will give you the true and false, true or false. So we'll have a lot of practice in Python. So don't worry, I will show you in details. So the logical operators and or not. Okay. So A and B. So if both operands like A and B are true, then the condition will be true. But for or, like if one of the operands is true, then the condition will be true. And for not, it's opposite. Do you know why? Like if the operand is false, then the condition will be true. Okay. So when you will practice in real data, you will understand more. Okay. So let's start in Python. Please open the following course. I hope you got this code. I already sent in the chat box. Even m.hawk can share again. So some people came here and late, so you can share. We have two courses, comparison or relational operators and logical operators, Python. Then I have shared the data in Excel file. So you need them. You can keep anywhere in your computer, in any directory. You know your directory, right? Then just use it. Let's share the screen. The same way we'll search the Anaconda. We need to open the Anaconda. And we'll change the path or directory I have in F. then cd change directory is the same the first class what we have done the same way. Then type Jupyter notebook and type enter. I hope we are all together, right? Is there anyone who are left behind? We're here. We have opened this code.
Yes, we did.
Yes, sir, we did.
Okay, so you need to respond. You need to respond. It's not good. If you are left behind, you also notify me, you need to notify me, or you can ask, okay, I'm there, I am there, or like this, right? Please respond. Okay, at the first, it's like a first lecture, we need to define the variable the similar way. Even, okay, you can run, or you can type like control plus enter, it will execute. Okay, the same thing, you can run. Okay, we have the comparison of relational operators. We can use a syntax, even we can use function, right? Okay, both way. So here, what I said, our output will be in Boolean, right? True or false. So what will be results in the first command? A is equal 5 and B is equal 6. So we are saying A greater than B. So is it true or false? What will be the output?
False, false.
It should be false, right? And what is the second one?
It should be true.
True. What is the third one?
It should be false.
False.
And the fourth one?
True.
Okay. And what is the fifth one, right? A
False.
is greater than equal B.
False.
All right. So what will be the last one?
True.
Okay. So what is the reason? Like, why the last one is true?
If A is either less than B or equal, have to equal B. There is two conditions. One means that is why the result should be true.
If there is two conditions, then if, like this is the or, right? If A is less than or equal, or something like, if one of the operands is true, then it will be true. Okay, let's run and see the results. Yeah, first one is false because A is not greater than B, right? This is false. Then yes, true, because A is less than B, because A is equal 5 and B is equal 6, right? Then third one false, then true. Yeah, and the last one also true. We can also use function, like what I said in the first class. We need to import the library, like operator. We can, we don't need to use the operator, the long word. So you can short it. So import operator as OP. You can give any name here. Okay. Then we can use dot GT is the greater than. LT is the less than. EQ is the equal. Any not equal. GE is a greater than or equal. Okay. Less than equal. The same thing. We'll get the same results. So either you can use either syntax or function. Okay, you'll get the same result. So who can say what is the real application? Can you give an example?
In business, we can meet I think you can think that there is many wages of people. Then I have something that the wages greater than 5,000. I need to convert them. So then I can use any operator, comparison operator, to find the result. Similar way to less than 5,000 or higher than 5,000, and many other uses can be.
Okay. So, okay, let's start with the real data. So I have this file, draw data. I have already shared this file. So the data is related to drought. You know, the drought, the water scarcity. If you are not from the climate science, it's fine, but it's very simple. We'll monitor drought, like the water scarcity, the dry climate for Rampur station in Bangladesh from 1994 to 1995. So here we have some threshold. Yeah. So this is an index like we can use to monitor drought. So there is a threshold. The positive value means the wet condition, negative value means the dry condition, like less water. If you have the water scarcity, then it will be considered as drought. So here, if we get the value 2 and above, then it's extremely wet, right? The similar way, if we get the less than equal -2, then it's extreme drought. If we get the negative value, then drought. So we can monitor in this way. So here we have a data, but we will just monitor 1994 to 95. We have 1983 to monthly data till 2017. Okay, we have the value there, and we can monitor using comparison or relational operator. Okay. Okay, let's run. What I said before, we need to import the Pandas library if we want to handle our data. So in the last class, I used the read CSV because in that file was in CSV format, right? Now our file in Excel format. So from Pandas, we can use the read Excel. The same way, you just give the name with the extension, then we use the head to print our data with default like 5 rows. Okay, so let's run and see the data. So you have the year and month column, then you have the SPI. What I said, these are threshold. Okay, then we want to only take the 1994 to 1995. Okay, so we need to index. We can index in different way. I will not talk more in this class because we have class like data analysis in the schedule. Just check in the schedule, we have the data analysis. So in that class, I will talk more. I will show different way how we could use Excel or CSV, different file. Okay, I'll talk more. But for now, I just show you the application of this operator, right? So 1994 to 95, right? From there. Yes. So it's row 134 because we have the header. We can also see this in Python. We can use the date and time parse. So we can see the date and time, but tonight I will not talk about it. What I said, I will talk in the data analysis class. Okay, so first a header. We have the one row is header. So it's now 134. That means 133. And we have the 157. That means 156. That's why index here. Data set. We want to access the SPI. Then the okay. What is 133 to 156? That's when we are checking only 1994 to 1995, right? And print it. We just took this data. Okay. Now we can compare our results, like we can monitor the drought. What I said, if we want to see the extreme drought, then SPI value should be less than equal -2, right? So we can use both syntax and function. So in the syntax, we can use the less than equal, -2, or we have the function like LE, less than equal. Then less than equal, it should be X and Y. So we have the data, then what is the threshold? Like what is the comparison, like what we want to compare, what we want to see, the -2. Okay, so less than -2 SPI value should be considered at extreme drought. Okay, let's run. So it's saying first 5 months or 6 months is saying false. There is no value negative, less than -2. You can see there is no value. That means it's false. Okay. Then other value has true. Even the same way we use the function, we can also see the same results. Okay. That means in these 5 months, there is no extreme drought. Now we can see the just true and false, but we want to access a data like Excel file. We want to see the amount and the SPI. So how to do that? Okay. So if we want to do that, we can access the data, like monitor the extreme drought for whole years and create a data frame as extreme. So here,
excuse me, Bhaiya, I have a question.
Okay, I will give you floor to ask question. Wait.
Okay, thank you.
Okay, so here we have the data set, right? We already defined the data set, and we have the year and month, and we have the SPI value. So we don't need to do one by one. Even we want to get the Excel file as an output. Like here, there is no output. It's just showing the true and false, the Boolean output, right? But we want to see the real results, a real output. Then we want to have the data frame like the Excel file. Then maybe we can save it in our directory. We can use further. Okay. So in this case, you need to access index, like we have the data set. Then from the data set, we have the SPI data set. Then we need to use the slicing operator. Okay, I will not talk more about the slicing operator because we have the schedule. Okay, I will talk more. So we need to use the square bracket. This is called the slicing operator. In here, we have the SPI. Then we use the comparison operator here, less than equal -2. Then we just want to take the extreme drought. We don't need the whole result, just extreme drought. You see? Now we can see the result. So it's saying 1994 in September, there was an extreme drought in Rangpur. Then in October, there was an extreme drought. Then November, there was extreme drought. In December, also even in 1995, in January, there was extreme drought in Rangpur division. So now we have the data frame. We can export it. We can save it. So this way you can access your data. Yeah, Salehin, you can ask your question. Saleh, Shakil, Noman. Yeah, sorry.
Yes. Bhaiya, I have a little bit confusion about you just showed last in your last few yes this one and a little bit upper and yeah here this is sorry Bhaiya, a little bit lower down. Comparison and relation operator by syntax and function in this row, and the extreme drought equal to -n, and what is the meaning of then -n? I just can't understand this.
Okay. So I talked in the first class, maybe you missed it. Okay.
Yes, please.
Use the slash, like if you, this is the printing format, right? Like
yes.
Don't use this slash. Okay, let's see the result. You'll understand. I have it, okay? And you see,
yes.
You just notice here, what was the output, right? Now, and now I will run it. You will see the result. What you can see the difference? Can you see?
Oh, yes.
What is the difference?
Same line.
Yes,
extreme dot equals same line.
Same line. If you want to print it out, the different line, like you define extreme dot is equal, then you don't want to see the results in the same line. You want to show the another line. Okay. So in this case, we use the /n. Then there is a format. You just search in Google /n is like next line. Even if you use the T, that it will give you the next step. So this is the option for. Now you can see the results. Let me run again and I see the results. You see the, yes. So for
Yes, thank you. Now I get it.
Google, yeah, the search in Google printing option like /N, T, R, there is different option in details. So it will be good for you for the next step. Yeah, this is very basic.
Thank you, sir.
Okay, thank you. Okay, Sakil Loman, where are you from?
Bhaiya, I'm from Austria, and my university name is University of Leuven.
So maybe if you use the Vaya, maybe some people will not understand because this is the international platform. So don't mind, please. So, okay, where are you from Bangladesh?
My bachelor is at University of Borishal, and my major was in
Okay.
geology and mining.
I got it. I got it. You have sent me email, right?
Yes, Bhaiya.
Okay, okay. We will talk over email, right?
Okay, Bhaiya. Thank you.
Okay. No, no. What I'm saying, we talked over email, right? You sent me email. Okay. Thank you so much.
Yes, yes, Bhaiya. Yes, Bhaiya.
Yeah, yeah. I got it. I got it. I got it. Anyone has question? Otherwise, I will go the logical operators. You know, in online, in Google, you will find some basic, like the simple example like A and B. But I wonder, you'll rarely get the example with the real data. Did you get my point? That's why I try to show you the real life, real data. You can use it in your real life, real data. You can practice it. Okay. Anyone has the question? Nobody. All right. So we can start. Huh? Any question? Takin, do you have any question?
No, sir, I don't have questions.
All right.
Hello, I don't have
you-
question.
You don't have question, right?
Yes, sir.
All right. So open the logical operator now. All right. In the logical operator, okay, let's define a variable a is equal 5. But here there is a difference. Okay, if you use the syntax like what I said, a, and, or, not, right? I already described, and if the both operands are true, then the condition will be true. If one of the operands is true, then the condition will be true for all, but the not is opposite. If operand is false, then true, right? But if you use this syntax, you can't work with vectors like in Pandas. We can't work with, because and, or not, logical operators are designed to work with scalars. So if you are aiming to work with the vectors, you can't use. So you need to use the function. But if you use the function, then we can use both scalar and vector data. Okay. Even we can use another logical operators or bitwise operators like and. Okay, let me type it. I hope you know this symbol. Okay, maybe you are familiar with this symbol, right? MATLAB is this and. So this is the bitwise operator. Even it can be done by this operator. I will talk another class because we have the schedule. But for not and or not, these logical operators only designed for the scalars. So don't try with this. Read more. I have given the link. You can read Stack Overflow. Okay, you'll find the answer. Okay, so here, what will be the answer? A is less than 10 and A greater than 0, what will be the results? We'll get the Boolean output, true or false. So what will be the output here? A is equal to 5. But here I have put the condition like A less than 10 and A greater than 0. What will be the output?
True. True.
Yeah, it's true. It should be true because the both operands are true. Okay. So what will be the second one? A is greater than 10 and A is less than 0. Sorry, greater than.
False. It should be false
Why?
because A is not greater than 10. A is less than.
Exactly. But second one is true. But if in case of AND, it should be like A and B both should be true. Then it will be true. Otherwise, false. If one of the operands is false, then it's false. That's why it will be false. What is the third one?
Then true.
It's false.
It should be true.
True.
Exactly.
true,
Because it should be true. Do you know why?
Because
this one, the second one is true. Because A is greater than 0. Because this is an OR. If one of the operands is true. First one is false, but another one is true. That means OR, alternative. So it should be true. What do you think? Okay. What is the fourth one?
Should be false.
I have a question.
Yes.
Please clear the third option. I still can't understand clearly.
For the OR means alternative. If one of the operands is true, like if one operand is true, then should be true. Because this is OR, this is not AND. OR means alternative. If
Okay.
one is true, then true.
Yes. Now I got it. Thank you. Yeah.
Okay. So what is the fourth one?
Should be false.
Exactly. Because both are
No operators.
no alternative. Both are false. And what will be the last one?
true.
Should be true.
Exactly. Because for the not is opposite. Like if operand is false, then true. Yeah, A is not greater than 10, right? So it's true. Because A is equal 5. Yes, this is very basic, but if you don't know this thing, you will suffer when you will analyze your real data. Right? So be careful. Yeah, first one is true, the second one is false, then third one is true, then false, then true. I hope I have described clearly. Any question, any confusion there? I think no. Okay. For the logical function, we can use both NumPy or we can use operator. You can use both, it's fine. Okay. I already described the operator library. So that's why here I use the NumPy. In both case, in both way, you can use the logical operator. Like in NumPy, there is a logical AND. This is a function, AND function. Logical OR and logical NOT. But in operator AND underscore or underscore, it will give you the same result. Okay, so you can use both. Here we can use the logical AND, but argument should be X and Y. That means two operands, two conditions there, right? First condition A less than 10 and A greater than 0, right? What do you use this? Same thing, but we are using the function. In function, you need to give the two arguments. Okay, the same thing. Let's run. It's true. Okay. Any confusion? No. Okay, now let's practice with the real data. The same thing, same data. But here we'll use, we'll import pandas and numpy. Okay, numpy for the logical function and pandas for the Excel file. Okay, the same data, same thing, what I said before. Now here, okay, one thing I need to know from participants. What is the difference between like logical operators and the comparison or relational operators? Like, can you give an application or can you give an example? What is the difference? When we can use the comparison operators and when we could use the logical operators? What is the application? Do you have any idea?
Comparison operator always use two data and they will compare between them. And while logical operator didn't need any two type of data, it will compare it among them. When I will put some logic, they will operate logically.
Yeah, but not two data, like when you have only two conditions, if you want to just compare X and Y, like then it's fine, the relational operators. But if you want to compare like more than two, you have more than two conditions, then you can use a logical. Okay, like sometimes both are true. Like you want to what say like I want to take the wet climate and also I want to monitor the dry climate. In that case, I need to use both conditions, right? And I need to put the condition more than true. So then we need to use the logic. But in relational operators, you just can use one, whether it's only dry climate, whether for just the the wet climate. You can't compare. You can't compare more than two. Okay. My internet is showing unstable. Can you hear me?
Yes, sir, we can hear you clearly.
Okay, thank you.
Yes,
Yes, sir.
we can hear you.
Okay, I will monitor like wet climate, dry climate, or not extreme wet climate. We need to know this thing. Here, we know the threshold, right? Well, you know the threshold. You're saying the climate was wet if the SPI values are greater than 1 and less than 2. Can you see? If you just use the operational, the comparison operator, we can just compare this. Greater than 1 or less than 1. But we need to use both. Then we need to use the logic. Okay. So we are saying if climate is wet, then SPI value should be greater than 1 and less than 2. Okay. And similarly, if the SPI values are less than 1 and less than equal -2, the climate was dry. So this is the real example from my field. Maybe you have the own data and you will apply your own field. Okay. So I'm saying here wet climate is we are using the numpy. What I said, if you use this and sentence, you can't use because it's only aimed for the scalar data. But function, you can use both scalar and vector. So for the vector, you can only use this logical function, logical and. Okay. So here we need to put two conditions, X and Y. Okay. So in a real life, I have the SPI value is greater than 1. What I said, if greater than 1 and less than 2. Okay. So SPI greater than 1 and less than 2, then it should be the wet climate and we can print it out. No wet climate. It's saying false. That means in 1994 and 95, there was no value. There is no negative value like the -2 for the dry climate or etc. It was positive value. Sorry. There is no value greater than 1 and less than 2. So that's why it's showing false. There is no wet climate. Okay, these are Boolean output. Then for dry climate, logical OR, because here, if less than 1, even less than 1 is dry climate, even less than equal -2 also the dry climate. You can see. So it's a dry climate. That's why I use OR, logical OR. Okay, if SPI less than 1, it will be also considered as dry climate. If SPI value less than equal -2 is also the dry climate. So that's why I use the OR. Anyone is true, the condition will be true. Wrong is true. That means the dry climate. Then we can print not extreme wet climate. Logical SPI greater than 2. So you can see there is no 2 and above extremely wet. Okay. So there is no wet climate, logical not SPI greater than 2. So positive true. This value is false, then it should be true. All right. Then we can create a data frame from this Excel file, and then we can export as output as Excel file. We can save it. Okay, these are real data, and from the real data we can access. So here, define the data frame wet climate. From the data set, we can use the square bracket. Okay, inside the square bracket, we can use the logical AND. This is our NumPy function, logical AND. Then we need to put the X and Y. So how to do that? In X, like from the data set, we have the SPI value, and SPI, it should be greater than 1. And from the data set, SPI should be less than 2. Then it will be wet climate. So for this way, we can, now we get the real value with Excel file. Even the same way, we can also get the dry climate. And now we have the Excel file. We can see the value and the real value. Okay. Do you have any question?
Can you please clear about scalar value and vector? It's scalar data and vector data. I am confused.
Scalar, only one value. There is no dimension. If I say only, okay, 140, what is the value? Only 1 point.
140.
This is scalar. There's no dimension. But if you say 140, 141, 142, then you have the dimension. Vector is you should have a row and column. Like this is a vector. I have the how many rows here? 5 rows, 3 columns.
5 rows.
3 columns. This is not a scalar. It has the dimension.
Okay, got it.
Did you get it? Yeah. Only like the scalar value 10. What was the results here? Okay. We define only A is equal 5. Then it's fine. This is a scalar. Only A is equal 5. There is no dimension. Okay.
Yes, I get it.
Any other question? No question?
Question, sir.
Yes, please.
Sir, what will be the file extension if we want to save a Python code? Like if we save a MATLAB code, then we use .m or .mlx, then what will it be for the Python?
Maybe you missed the first class, right?
No, sir.
So I talked about the file extension, file types. .py is a Python file, .m is a MATLAB file, .ncl file. So if this is a Jupyter notebook, even you can download as a Python file. Can you see here? In file,
Yeah.
you can download as, then you will get .python. Okay, click on it and you will get it. It's saying, okay, keep. This is a Python file. Let me open it. This is a Python file. Can you see the same thing?
Yeah.
The Python .py.
Okay, sir, I get it. Thank you.
But I will not give you the answer how to export this Excel file. No, I have another class in data analysis. I will not talk that one here. Any other questions? No? So if no, we can finish.
Yes, sir. No question.
Okay. Thank you so much. Thank you so much. Okay, we could finish the class. Okay, thank you so much. Good night.